Here we have the nasal septum. Septum meaning that it's going to separate a compartment. That's why when we have a deviated septum, means that this septum is either going to one side or to the other side and makes it hard for individuals to breathe. But the nasal septum is going to be formed by two bones, the fusion of two bones. The bottom bone is what we call the vomer, and the top bone is actually a feature of the ethmoid bone, and it's the perpendicular plate. So reviewing the nasal septum, which is all of this, it is formed by the fusion of two bones, the vomer, which is the bottom half, and the perpendicular plate of the ethmoid bone. And if we look over here, we can still see part of the ethmoid bone right over here. So this little structure that's sticking out over here is what we call the crista galli. And the structure with all these little holes over here is the cribriform plate. So all of this is part of the ethmoid bone together with the perpendicular plate that forms the nasal septum. The other bone that we should be thinking about is your zygomatic bone. So you're going to have a zygomatic bone on one side, a zygomatic bone on the other side, and these are your cheekbones. Another bone that we talked already a little bit about is the temporal bone. The temporal bone has several features that we are going to talk about now. The first feature can be the mandibular fossa right over here that we talked about earlier. And the mandibular fossa is going to articulate, remember, with the mandibular condyle that's present in your mandible. The other structure is the external acoustic meatus. Now the external acoustic meatus is going to connect to the internal acoustic meatus. So external meaning that it's on the outside. And if you come over here, you're going to see the internal acoustic meatus. So internal, inside, external, external on the outside. Couple more features of the temporal bone is your mastoid process, which is this big bulky process that comes out over here. And the other one is your styloid process. So if you think of your stylus pen, that's what it looks like, a little pointy structure right over here. One more that I was forgetting is the carotid canal. So the carotid canal is part of your temporal bone right over here. And the carotid canal corresponds to the jugular foramen. So you had the jugular vein passing through the jugular foramen. You're going to have the carotid artery that's going to pass through the carotid canal. Now on this model, this hole does not go through, but on us, it does go through, right? So the carotid canal is the artery that's going to take the blood from the heart directly to your brain. So it has to go through from your heart all the way up to your brain. So it does go through. So we do not have a carotid vein and we do not have a jugular artery. These are the ones that correspond to each other. So the jugular vein corresponds to the carotid artery, and because they correspond to each other, they run parallel to each other. So the jugular foramen is present on the occipital bone, while the carotid canal is present on the temporal bone. Now the last bone that we are going to talk about here in the skull is your sphenoid bone, which is that butterfly-like bone. So you can see it right over here. It forms like a little butterfly. So there are certain structures that we want to talk about. So let's look at a couple of them from this angle right over here. So this hole over here that's round inside of the eye is your optic canal. And if you follow it over here, you're going to see where it comes out. So it comes out on the other side. And that's where your optic nerve is going to pass through. So your optic nerve passes through the optic canal and comes all the way over here to the back of the skull, because that's where your visual cortex is going to be. So all the visual information enters the eye and goes all the way to the back of the brain. The other two structures that I want you to see are these two fissures over here. So you have one that's on top and one that's on the bottom. So the one that's on top, it's called superior orbital fissure, and the one that's on the bottom is called inferior orbital fissure. A lot of times you guys get the orbital fissures confused with the supraorbital foramen, but remember, fissure is this elongated passageway, so it's different from a hole. Now it's important for you to notice that the superior orbital fissure comes out inside of the brain, but the infraorbital fissure comes down right over here, so you can't see it from this angle over here. Okay, so make sure that you trace them out when you're in lab. A couple other structures or holes that you need to know are these three holes right over here. 1, 2, 3. So this is your foramen rotundum because it's round. This one is your foramen ovale because it's oval. And this little tiny one is the foramen spinosum. So if you remember ROS, R-O-S, you know the girls will remember because they like to go shopping, right? So think of the store Ross. So you go R-O-S for rotundum ovale spinosum. The last thing that you need to know here is the sella turcica. Now the sella turcica is this saddle, looks like a horse's saddle right over here. And this is where the pituitary gland is housed, right over here in this little compartment. Okay.